It's pretty wild when you think about it, how one single design decision made decades ago can shape the entire history of a piece of software. Well, today we're diving into the story of MySQL and the one core idea that let it not just survive, but absolutely dominate one tech revolution after another.
And it all really boils down to something as simple as this. Engine equals MySQL. Or maybe engine equals InnoDB. It's just one little setting, a single choice. But how in the world can changing one word so radically change how a database works, how it performs, even what it's for? That simple question? Well, that's where we find the genius of MySQL.
The answer is this absolutely brilliant concept called a pluggable storage engine. Okay, think of it like this. Most databases are built as one big solid block. The part that understands your questions is fused to the part that actually stores the data. MySQL did something totally different. It split them apart. It separated the brain that processes queries from the hands that physically handle the data. So you need lightning speed? Cool, plug in this engine. You need absolute bulletproof reliability? No problem, just swap it out for that engine. And this quote just nails it. Instead of being a single hammer designed for one job, MySQL was a complete toolkit. And any good toolkit has a whole range of specialized instruments, right? A wrench for this, a screwdriver for that. This whole philosophy of choice is what allowed it to thrive. So what was the first big problem this toolkit had to solve? For that, we got to jump in the time machine and go back to the early days of the dynamic web. Back then, the number one challenge wasn't about complex financial systems or anything like that. It was just one thing: speed. Raw, unfiltered speed.
I mean, think about the kind of websites that were exploding back then. Blogs, forums, the first content management systems. These sites were overwhelmingly read-heavy. For every one person writing a comment, you had thousands, maybe even tens of thousands of people just reading the content. The system had to serve all that data up as fast as humanly possible with basically zero overhead.
And the tool for that job was MyISAM. It was the speed wrench in the toolkit. It was super lightweight, ridiculously simple, and it was optimized for one thing and one thing only: blazing fast reads. It didn't mess around with complicated stuff like transactions, which made it incredibly lean and mean. For a whole era of the web, MyISAM was the engine that powered pretty much everything. But of course, the web never, ever stands still. So as the web starts to grow up, a completely new demand shows up on the scene. It wasn't just about reading articles anymore. Now, people were spending money. E-commerce was starting to take off, and with it came this absolute, non-negotiable need for reliability. And this gets us to the heart of the problem. MySQL was awesome for a forum, sure, but what happens when a financial transaction fails halfway through? What if the website takes the money from your account but then crashes before it tells the seller they've been paid? All of a sudden, MySQL's biggest strength, its simplicity, becomes its most critical weakness. So this brings us to this fundamental trade-off. You could think of MySQL as the race car, built for nothing but speed, but it has no seatbelts, no airbags. For e-commerce, you needed an armored truck, and that armored truck was InnoDB. It was built from the ground up for safety, for something called ACID compliance, which is basically a set of guarantees that your transactions will be processed reliably every single time. It was the bedrock that serious business could be built on. Let's just walk through how this works, because it's pretty cool. An InnoDB transaction is an all-or-nothing deal. So imagine a bank transfer. Step 1, take the money from account A. Step 2, put that same money into account B. And only if both of those things happen perfectly, does the system finally commit the transaction, which makes the change permanent. But here's the real magic. What happens if something goes wrong? The power goes out, the server crashes, whatever. If any single part of that process fails, InnoDB screams rollback. The entire operation is just undone, instantly. It's like it never even happened. No data gets corrupted, no money is left floating in limbo. This unbreakable safety net is what made the e-commerce boom possible on MySQL. But the challenges just kept getting bigger. So next, we enter the world of telecommunications, online gaming, high-frequency finance. We're talking about industries where reliability isn't just important, it's everything. Even a few seconds of downtime could be an absolute catastrophe. For this level of need, MySQL brought out its power tool, NDB Cluster. This was a whole different beast. This wasn't just about one tough machine anymore. This was a completely distributed system with data being copied in real time across multiple machines. The goal was something they call 5 nines, 99.999% availability. It means that if one server completely dies, the system just keeps on running without missing a single beat. This is what let MySQL play in the big leagues, with the most demanding businesses in the world.
So when you step back, we've seen this incredible journey from simple blogs to complex online stores to massive mission-critical systems, all of them powered by the same database. And that brings us right back to the central lesson here, the legacy of that incredible flexibility.
You can literally see the history of the web right here on this timeline. Each big evolution created a brand new problem, and that pluggable architecture allowed a new engine to show up and be the perfect solution. First, MySQL gave us speed, then InnoDB gave us safety, then NDB gave us non-stop availability. And it didn't stop there. New challenges like big data analytics brought even more new engines. Each one was a direct answer to what the world needed next. And this gets us to the critical truth. The real innovation, the real genius of MySQL wasn't any one of its storage engines. It was the architecture that made all of them possible in the first place. By building a framework based on choice, MySQL guaranteed its own survival. Adaptability wasn't just some nice feature, it was literally baked into its DNA. And that really leaves us with a fascinating question to chew on. This story isn't just about databases. It's a huge lesson in how great software is designed. So as you look at the essential tools you use every single day, ask yourself, what are the foundational choices that define them? And how does that flexibility, or maybe the lack of it, determine what that software can and can't become?